you very much, and it's a real pleasure to be here. Sorry. So, I will first of all make sure this is working. Great. So I'm going to talk on the importance of token economics in on-chain analytics. But I think I'm really going to talk about on-chain analytics in a very sort of broad terms, and some lessons we've learned as we've done that at Chainalysis. Because if you think blockchain is a big topic, doing data science and on-chain analytics goes even deeper. So if you've got questions, please queue them up, and really happy to answer them afterwards. But I really wanted to say that for blockchains to go mainstream, we really do need data science. And to illustrate that, this is actually in Coinbase's pitch deck that they put together in 2012. So Coinbase, one of the most successful businesses in cryptocurrency, you'd have liked to have been in that venture round in 2012. They basically used data to justify what they were doing, and they were saying, look, at the time there was about $2 million per day of on-chain transaction volume, and it's now in the hundreds of millions, if not billions of dollars per day of transaction volume. So if back in 2012, trying to make the case for Bitcoin, Brian Armstrong was using data, now we really need to use data more and more to actually explain what this industry is and to explore the opportunity. Just a few words about Chainalysis. So we are a blockchain analytics company. We use the data that we collect from the blockchain. We then process that, augment it, and I'll explain what that is in a bit more detail. And then we use that data to provide a couple of products. So we provide an investigations tool, say if you're law enforcement, because the first use case of cryptocurrencies was to buy drugs on the internet. And so for cryptocurrencies to go mainstream, law enforcement needs to know that they're actually happy and they can understand what's going on. And so we provide software that, if you like, makes it feel safe for them. And then we also provide anti-money laundering software for exchanges. Exchanges really are one of the big businesses in cryptocurrency. It is currently an asset of financial speculation. They need to check whether the Bitcoin or Ethereum or whatever that they're receiving and sending, that it's coming from sources that follow the laws of the land where that business is operating in, because they operate as what is called like a money service business. So they have to face those regulations if they want to continue to operate. So we provide software that helps those law enforcement agencies, that helps those cryptocurrency exchanges, and we also provide software that gives data to financial institutions. So really, if we want to get more people into cryptocurrency, we need to understand there needs to be an on-ramp from the traditional financial world into the crypto world. And really that will be through a lot of the big banks who've got towers behind us and in front of us. And so they need data to understand the businesses that they're getting involved in, so they can offer bank accounts to some of these exchanges. So that's really what we do. But to really give you a bit of an introduction to what data exists, when we talk about blockchains, in a sense, they are big databases. They are actually the records of transfers and transactions between people, but that's not the only data in the industry. But really starting with the data on the blockchain, that's what we call on-chain data. And really what you see on the blockchain is what we have over on the right here, or on my right. We have all these strings of letters and numbers, these addresses. And the thing is, any individual or any entity, any business can have as many of those addresses as they want. They are free to generate, more or less. And there are some exchanges that have tens of millions of addresses. And we don't know who's behind them. They are pseudo-anonymous. So it's kind of right, rather than saying, hey, write my name Philip, I can get a string of letters and numbers that represents me. And if you're just looking at that data, it's not very intelligible. What you have to do is you have to try and understand, who is the entity behind that set of addresses. And that's core at what happens at Chainalysis is, for example, with this set of addresses, that's actually a set of addresses from a service called Coinify making a transaction to Bitstamp and exchange. And so really it's about mapping what we call these addresses to entities that's at the first stage of doing on-chain analytics. Now, to do that, there's really two crucial steps. The first is that you have to get some ground truth attribution. How do you actually know that these addresses are part of Bitstamp? Well, honestly, the gold standard way of doing that is to actually go and make a transaction with Bitstamp. So to create an account, go, transfer some Bitcoin into an address that you know is there, and then send that Bitcoin, back. Only by doing that can you really get that ground truth. You know that address is part of that service. There are databases of these addresses out there. In Ethereum, there's many more addresses labeled than there are in Bitcoin. I'll go through some resources at the end. But that's really probably the hardest and certainly most resource intensive part of doing, data science for blockchains. The next stage, once you've kind of got that ground truth, is to understand, okay, I know one address out of currently, I think in Bitcoin, there's sort of maybe 580 million addresses that have had Bitcoin in them. So which ones from this one that I've now identified as belonging to a service are also part of that service? And there are a number of ways in which you can do that. For example, in Bitcoin, there's a heuristic that's well known called the co-spend heuristic. So that means if a set of addresses have contributed to the same transaction, that means, we talked about private keys earlier, they must all be, there must be a single person that controls all the private keys that allowed value to be put into that transaction, that signed that digital message. And so understanding, look, all of these addresses are co-spending together, they're all providing inputs to a transaction. That's one way to understand that addresses can be grouped together. And then, there's various ways, various other heuristics that you can use to try and aggregate these addresses together. Some of them, it's what we spend a lot of time at Chainalysis thinking about. I can try and answer some questions on some of those later, won't answer all of them. But again, that's a key next step to doing this on-chain analysis. Get some ground truth, identify that these addresses belong to services, and then understand how many more addresses belong to those services. Once you've done that, you can move from this data set that looks just like letters and numbers into a data set that looks a lot more like people and businesses actually transacting on the blockchain. And once you've got that, you've kind of got this really interesting economy, that actually you don't have that data set anywhere else in the world. If you look at fiat transactions, if you're in a bank, you might say your Barclays, you'll only see the transactions in the Barclays payment network. But once it goes over that line, cool. Thank you. Once it goes over that line, you can hear me now, cool. If you've got any questions, because you haven't heard what I've just been saying for like the last 5 minutes, do raise your hand. So if you're Barclays and you see that transaction go over the, to HSBC, you'll lose sight of that. But in cryptocurrencies, we have a complete transparent record of all of the transfers. So that's kind of what makes it a really exciting data science problem. But on-chain data is not the whole story. I guess because we really spent a lot of time talking about what's on-chain, we call everything else off-chain, but that's a very big group. So there is data that's not on the blockchain that is still relevant to understand if you're trying to do some analysis. Really, I think for me, breaks down to two. There's trading data. So there are hundreds of exchanges. So, I talked about Coinbase and Bitstamp, but, there are hundreds. They trade 24/7, 365 days a year. They trade thousands of pairs. So there are lots and lots of different cryptocurrencies, and they are trading them. Obviously not as much as some of the big ones like Bitcoin or Ethereum or Tether, but there's a lot of data. These exchanges, it's important to understand, they have what we call varying levels of custody. So they range from these big centralized exchanges, where actually when you send cryptocurrency to them, you essentially give up your private key and you essentially get a sort of legal promise that they will give your Bitcoin back to you in return. That's how most exchanges operate today. But there are peer-to-peer exchanges and decentralized exchanges that are coming. The reason that from a data perspective, why that's interesting is because on a centralized exchange, when you give them your Bitcoin, the Bitcoin essentially goes into what we call like an omnibus wallet, or indeed many, many different addresses and gets moved around. And so it can be hard to understand, does this Bitcoin belong to a single person, or is it being mixed up with all the Bitcoin in that exchange? And also it can be really hard to actually understand which addresses belong to an exchange versus which belong to a person who's interacting with an exchange. So, thinking about if you're ever trying to model exchanges and understand the addresses that belong to them, you've really got to think about their custody model and how they hold cryptocurrency on behalf of other people. That is getting quite deep in the weeds, but it's important. And then I should say in the off-chain world, there is spot markets, there's derivatives markets. So there's like order books, executed volumes, prices. There's like terabytes of this data. Okay.
This one is working.
Amazing. I mean, is it super important?
They are making it on purpose. I'm sorry about that.
Okay. No worries. Thanks. Yeah, and then I think the other really important thing to understand about off-chain data and about cryptocurrency in general is the need for context. So there's lots of open source intelligence, i.e. Reddit, genuinely, or Bitcoin Talk, or just like cryptocurrency, it evolves very, very fast. And a lot of what you will see in the data, you'll go, why is this happening? And you will have to go and check, was there some crazy news today? So, a couple of weeks ago, Xi Jinping said blockchain is like the future for China, and the price just jumped. And if you're trying to do some statistical analysis on this, price series, and you suddenly see that kind of jump, you won't see that in the on-chain data. You have to go and see what happened in the news that day. So that's why we also got news and events. And also people do talk a lot about sentiment. Can they look at Twitter and try and understand whether people are saying, good things about crypto or bad things about crypto? I honestly think that's actually pretty hard because people just say a lot of shit about Twitter, about crypto on Twitter. So I think that's kind of hard, and I respect the people trying to do that. But that's definitely an area that people really do try and dive into in this industry. Essentially because the conversation about cryptocurrency really does happen online. And then, I kind of have a bit of an analogy that I think helps, at least me, understand the relationship between on-chain data and off-chain data. If we think about cryptocurrencies as, an asset, say something like gold or, grains or, rice or whatever, that are sold in various different, open cry markets dotted around the place. In a normal fiat world, all that you can see are the prices that people are shouting out. I want to buy gold for this many $1,000s, and I'll buy it for this many $1,000s. And you see that conversation happening in these 5 different markets. With cryptocurrencies, so that's the off-chain side. The prices people are kind of shouting out to buy or sell. The on-chain data, that's the equivalent of actually being able to see, how much gold is in that person's kind of chest that they've got next to them, how much is actually loaded up in, big vans to be driven to the next market, and how much is on the way. So it gives you this extra level of data and insight about this commodity. In some ways, cryptocurrencies are sort of like digital, physical commodities. You can actually see where they're flowing on the blockchain. And that's what's fascinating about looking at both the on-chain data and the off-chain data. And I'll go through an example of that very quickly from some work we did pretty recently, just to illustrate that point before I get into a bit more of the kind of lessons of data science around this. There are like 10 exchanges, very big ones, that a company called Bitwise said, look, they've got kind of real volumes, i.e. real trading volumes, because people will often fake the trading volumes that they report. It's a bit like search engine optimization. You want to be the exchange that claims to have the most trading volume. And it's very easy to fake that because you can just pump it out of your API with a multiple of 10. But your on-chain data is much harder to fake because you actually have to own the cryptocurrency before you can move it. And so this Bitwise 10, they've got a trusted amount of data, and we see they're trading around 1.3 million Bitcoin per week at the moment. And on-chain, they're receiving about 213,000 Bitcoin per week. And that gives us a ratio of about 6 to 1. So there's about 6 Bitcoin being traded for every one that moves on chain. And obviously it varies over time. But this was really fun to put together because we were able to suddenly see, look, there is some relationship, right, between the off-chain data and the on-chain data. And this makes sense. You've actually got to send the Bitcoin to an exchange before you can sell it. But then once a Bitcoin is sold, there is, an amount of trading activity that happens. And on these exchanges, it's about 6 to 1. There was a report we've got on our blog, which then goes into other exchanges that, people thought faked volumes. In 2018, it looked like they did. But actually, in 2019, it looks like they've come into line and they've got a very similar ratio to the Bitwise 10, which again, that was cool. We were able to use on-chain data to actually answer what had otherwise been, a big mystery and source of, fear, uncertainty, and doubt in the industry. But, something that I found particularly interesting in this is, yes, we can use this on-chain data to verify some, off-chain data, but we could even use the on-chain data to perhaps make predictions about what we might see happening in the markets. So what I'm showing you here is the week-on-week percentage change between those trading volumes and those on-chain volumes. So a week-on-week percentage change means, if I was trading 100 Bitcoin last week and I'm trading 150 this week, I've had a 50% week-on-week percentage change in my trading volume. Now that change in trading volume is in orange and blue is the on-chain volume. And we're actually seeing, essentially these are 2 time series just shifted by a week. So the trading volume is lagging that on-chain volume by a week. So again, makes sense. Bitcoin is sent to the exchange and then trading happens after, but it happens in a very regular pattern. And again, if you're thinking about what type of thing can I identify in any data science project I have, trying to understand, can you use this on-chain data to verify some story or question the industry has? It's kind of a fun thing to do, and it's really possible. So, kind of really going to the question of why should you think about the token economics? What is it, when we're doing data science around cryptocurrencies, you've got to realize that, they're being used by people to do things. That's what's generating the data set. And so if you think about that, it can help you make sense of it. Blockchains and cryptocurrencies, they are a technology, but they're a technology being used by people. And that is really what explains the patterns in the data. So I'm going to hopefully share a few of those insights that might help in you guys doing some analysis. So the first one, everything follows a power law. And this is probably a bit of a weird thing to start with. But it's kind of a bit of a running joke within my team, because whenever we look at things like the distribution of wealth amongst addresses on the blockchain, there are a very small number that hold most of the wealth. And then there's a very long tail that holds, a very small amount of the wealth. But it's not just the wealth distribution, it's also the number of transactions. So there's a small number of addresses, or what we call clusters, these groups of addresses that actually do the vast majority of the transactions. But then there's a very long tail. It even transfers to talking about the businesses in this space. There's a very small number of exchanges that drive the vast majority of the volume, and then there's a really long tail that have small amounts of volume. And the reason why this is important if you're trying to analyze the data is it means you can really focus your efforts up here, but you do need to pay attention to this long tail, because often something might happen in the long tail that is driving events. There's a price change somewhere, or there's a flow of funds, and that can affect what happens up, in that right-hand side. The other thing that makes cryptocurrency a bit special is when you think about it as a flow of transactions, it is what we call a transaction graph. So in the previous presentation, we had lots of circles connected to each other, connecting other circles. Like mathematically, that's a graph. And that is, I guess, a particular data structure and has various ways you can analyze it. But the key point in relation to thinking about it as a power law is there's a few nodes in that graph that are very highly connected, but they're connected through millions of smaller nodes that don't have so much volume going through them. So you get quite a sparse graph, but you need to really understand the connections of it all. Sorry, that again might get a bit technical, so happy to take questions on that later. But for me, that's one of the key insights for thinking that everything's a power law. The different protocols, they generate different types of data. So we're looking at two cryptocurrencies here, and we're actually looking at that graph for, I think, transactions in a small set of blocks. And I'm kind of interested if anyone has a view of which one's Bitcoin and which one's Ethereum.
Right is Bitcoin.
My right or your right?
My right.
So,
Bitcoin.
Interesting. This is Ethereum, actually, and this is Bitcoin. And I'll explain.
Why so many stars?
So Ethereum is what we call an account-based model. So that means, essentially the balance of your addresses is actually preserved, whereas in Bitcoin, it's what's called an unspent transaction output model, or a UTXO model. Now, I'll actually explain the UTXO model first. That means, if I've got a UTXO of 1 Bitcoin and, I want to give you 0.9, I need to send the other 0.1, and I'll often send it into a new address. And that creates this sort of branching pattern. And you can actually see here, we've got these chains of branching transactions going around. You can see that here as well. Whereas in Ethereum, you don't have that. You don't need to create more and more addresses in this branching pattern. You can actually send your ETH, directly to another counterparty and not have to generate a new address. But you see these stars because sometimes it's actually really helpful to create a new address in Ethereum because you're just trying to keep track of where things are. And then this actually does come to the final point on this little section, which is to say services are really key to understanding what's actually going on in cryptocurrencies. It is almost one of the ironies that, yes, this is a decentralized system, but so much activity actually flows through centralized services. So, I've got to keep the time a little bit, so I won't dive into this a huge amount. But this circle actually represents all the value flowing between services in Bitcoin in the last decade, and at least half of it is, going to or from exchanges, and actually the majority of it is, between exchanges. So really understanding that ecosystem is really important to understanding most of the activity. So then some very final thoughts. In the interest of time, I'll pick out a couple of these. I've talked about, everything's a power law. We've got to try and get ground truth. Sometimes things can be difficult trying to understand, is this an exchange or is this an individual? But perhaps the other two things I'd highlight are you need to think about how you can check your results. This is a new area. There's not many benchmarks. So it's kind of easy to do some analysis and actually it to be totally wrong. And you don't know how or why. So it's important to talk to people, try to work out how to sense check things. And then I think the final thing really to say is that people do weird things on the blockchain. So if you're looking at some data and you're like, this doesn't make sense, that might be because it doesn't. It might be because you got analysis wrong, but it might just be because something weird happened. Just to finally say some selected resources, there's loads of resources on this type of thing. These are some things that people might not know. If you want sort of free Bitcoin attributions, there's Wallet Explorer. If you want free Ethereum attributions, Etherscan is a great source. There's some free trading data on cryptodatadownload.com. If you want to dive into the world of blockchain transaction types, BitMEX Research and Coinmetrics just released txstats.com. And also check out the blocks, their research compendium. It's a really good set of things. So yeah, I hope that was a bit of a whistle-stop tour through blockchain analytics. Feel free to find me and ask some questions. Thanks.
Thank you very much. Does anybody have any question?
Cool, go for it.
Yeah, let me just bring this to you so we can all hear you.
Yep. Yeah, there we go. Cool, go for it.
So I know one of the things quite famously this year was detect human trafficking, I think it was.
Yeah,
the business.
actually, so there was a case called Welcome to Video, which was actually about like child sexual abuse material. People do also do human trafficking, paying in Bitcoin, and we have helped do that as well. Yeah.
And congratulations, that was an amazing use case to talk about.
Yeah.
But I guess one of the things I was thinking about when I saw that being published was sort of cross-chain analytics. You have a good example there of Bitcoin and Ethereum and two different networks that act very differently. So I was building a model to detect activity on one chain, and then people know that you guys look at Ethereum and Bitcoin, so I'm going to swap to like Litecoin or whatever to avoid you. So do you look at cross-chain analytics as well as another way of seeing if people move from this cryptocurrency to this cryptocurrency?
Yeah, so I mean, it is something, we're in there's a couple of my team in the room are in the sort of research side, and so we do, think about that. Cross-chain analytics is particularly hard, but it is something you have to do. We do know that people will swap into one crypto and then they'll swap into another. The key thing there, I think, is to understand almost like the services they're using to do that. So they're like coin swap services, and people go through that, and that can help you make that link. I think the other thing that's really important to doing it is actually the abstraction from addresses to entities. We're really thinking about actually not the individuals that are using cryptocurrency, but the businesses. That's really what we track. But if you understand, this is a business that acts almost like an elevator between these two cryptocurrencies, that can help you understand where people are kind of coming in and going off between different cryptocurrencies.
Great, thank you.
There's, like a personal opinion that certainly Bitcoin is perhaps almost too transparent to be used in a mainstream way. Like if I make a transaction with you, you can basically see the entire history of my transactions, and that's not how our current financial system works. At the same time, I think in all technologies, privacy is almost like an equilibrium value. The people that think, look, you need absolute privacy, and people who are like, you need absolute transparency, they actually just don't work as extremes in a society. So I really think that there's kind of this healthy battle between different types of technology that hopefully gives us some type of equilibrium. On the one hand, we can't prosecute cases like Welcome to Video. On the other hand, does money work if we can see everyone's transactions? So, I honestly think we'll see a lot of development in technology, and it's going to be that, counterbalance between, as it were, both sides, really.
Couple of questions. Can we actually find out where the origin where the currency transaction is originating, so we can know where it's being traded majoritarily? And the second question I had was, so in a way, we're looking at on-chain analysis, we can actually know which public keys hold the most wealth. So we can actually do that?
Yes, so just to take your last question first, which public keys hold the most wealth? You can identify which public keys hold the most wealth in terms of which string of letters and numbers does. Which entity or person, you have to do more work. And honestly, which person, that's basically impossible. And then in terms of your other question about knowing where a transaction happened, where becomes a slightly philosophical question in cryptocurrency. So we can say this originated from an exchange. That's a concept of where, if that makes sense. Where does it happen in the world? Honestly, we have done some work on that. And there that's where we've actually merged the off-chain data, i.e. this exchange tends to serve customers in this region, or they follow really strong diurnal patterns, so we can apply time zone analysis. But in terms, cryptocurrency transactions don't come with a geotag. So yeah.
Last question, maybe anyone? Yeah, one more. Yeah.
This might be kind of a silly question, but what's the benefit of having, you said a service would have maybe tens of thousands of accounts, right? What's the benefit of having a bunch of accounts as one service? And then do you see services switching accounts, so making accounts go dead and then bringing up new ones constantly?
Yeah, so often it's really helpful to have multiple addresses to keep track, say, as people are making deposits. You know, you're like, okay, someone's just sent me a Bitcoin. If I was using the same address for multiple people, whose Bitcoin did, you know, who just sent me that Bitcoin? And then, you know, if you've got like a UTXO blockchain, whenever you make a withdrawal, you'll be making what you call these change addresses. And then services, they also spend a lot of time managing their internal treasury. So I'm sure you've all heard of like crypto exchanges being hacked. That's where someone just like does a phishing attack, gets hold of the, you know, the private keys because they're sitting on someone's computer, and then like in one click can send like millions to hundreds of millions of dollars worth of cryptocurrency out, and it's gone. So to manage that risk, these companies, they keep a relatively small amount of cryptocurrency, like on a laptop connected to the internet, and they keep a lot more what's called cold storage. And they will change that structure relatively frequently. You know, sometimes for good reasons, sometimes who knows, you know, like I'd love to go talk to some of the people that maintain the wallet structures at some exchanges and be like, what are you doing? But yeah, like hard to see into those minds, and kind of quite rightly, they are the guardians often of really quite vast amounts of wealth. So it makes sense that they want to try and make their wallet structures complicated and change them and refresh them and develop new security models. I would do that.
So thank you very much, Philip. A big round of applause. Thanks for coming today.